My apologies that I did not get stuff uploaded yesterday. My time was completely monopolized by the calculus class. Here we go. So find the dimensions of the largest area for rectangulars bases on the x-axis whose corners are on the parabola at 12 equals y equals 12 minus 3x squared. Okay. So I've got a parabola. Okay. And I've got a rectangle that's it sits inside there. So that means its base is on the x-axis. And its corners are up on the edges. Okay. And what's my goal? What do I want to do? Find the dimensions that give the largest area. So I want to try to maximize the area. So area is what of that shape? Length times width. I'm going to call it base times height. As long as we got two dimensions, that's fine. The reason why I'm going to call it base times height is they refer to the rectangle as having a base on the x-axis. So I've got that. Well, oh boy. Good thing we're the best of the best, huh? What to do? Well, that spot's 12. I'm going to call that coordinate xy. Does that give you a hint? What's that? Very good. So what's the length of the base? Two x. Very good, Jessica. If you look, I go x units in each direction in order to come up with the base. Way to go, Jessica. You're a genius. Now, what's the height? Yeah, the height is y, and so we have areas equal to 2x times y, but oh shoot, that really didn't help. We still have two variables. Shoot, if we only knew what y equaled. Yeah, it's right there. Right? Like, for example, suppose x was 1, what would you do to come up with y? You would plug it in. You would do 12 minus 3 times 1 squared, and you would get 9 in the end. So if you want to come up, if we have a value of x, we're going to plug that x in, and you do, in fact, get 12 minus 3x squared. And so, therefore, we have an equation for the area. We are in terms of x, and it is equal to the base, which is 2x, times 12 minus 3x squared. So my area in terms of x is 24x minus 6x cubed. Does that make a parabola? No. If it doesn't make a parabola, then we have to go to our calculator. This is the shape that it makes. It's still not a parabola. I mean, it's kind of like this, Grace. Say y equals 2x plus 1. That's a line, right? Well, if I have y equals x plus 1 times x minus 1 times x plus 2, it's not like that's a line either. That's now a cubic because it's x to the third power. So we cannot simply factor out an x to get the x squared. We do, in fact, have a cubic, and so we need to consider that graph. So the question is, would you be able to come up with the graph? Would you be able to see it on your calculator? And a lot of people get to this spot, and they type it in, but they don't know what they're looking at. So minus 6x squared, is that what I have? Cubed. And as I zoom standard, zoom 6, you can see that I can't see the top here, can I? So I'm going to change the window so that I draw the x values a little bit closer together. And I'm going to go up higher for the y values. Now, a lot of times people just don't choose a big enough number, so I'm going to choose 100. Looks like that should hopefully be plenty. And now I press graph, and sure. Did I really need to go up to 100? No, but I can see the maximum. That's all I want to see. So I calculate number 4, the maximum. Make sure I'm to the left of the max. Make sure that I'm to the right of the max. And I have a grand total of 1.15 and 18.48. So, what do those numbers mean? That is the maximum value, but of what? Look back to your equation. What does your equation tell you? Tells us the area. Very good. This is the area. That is the maximum area. This variable is x. What does x represent? I don't know. We got to look back to the problem. Looks like x represents how far over we go. So if we want to know the base, is the base 1.15? It's 1.15 times 2. Okay? It says the base is twice the x value. We found the x value. We want to go twice the x value, so we get 2.3 by, now that I have 2.3, and that's the base, how do I do the height? Do I plug in 2.3 or do I plug in 1.15? Yeah. The height says that it is 12 minus 3x squared. So we take our x value, which is 1.15, and we plug it in, and that will give us the height. You could do that as well. So Grace is saying, well, if this is the area and the 2.3 is one of the dimensions, could I not divide those to get the other dimension? That's absolutely fine, and that's a good way to check and verify your answer, right? So if I take this 1.15 and I plug it in, and I go 12 minus 3 times 1.15 squared, I get 8.03. Now, I'm going to do what Grace suggested. I'm going to take the 2.3 times the 8.03, and I hope I get a value that's close to the 18.48. Why am I off a little bit? Yeah, my rounding. So, but looks like we're getting what we want. So, what do you think? Okay. Grace is saying that she's not going to sit at home drawing parabolas and putting, boxes on the inside. She's going to try to make money someday. So she wants something to do with money. So we're going to look at a money problem. Okay. All right. We got a hockey team, and they play in an arena that has a capacity of 15,000 spectators. Okay. 15,000 spectators. Ticket price is set at $14. Average attendance at recent games has been 9,500. A market survey, so that they go and find a firm that can tell them how to kind of try to improve business. And they say that if they take the cost and they lower it by $1, then what's going to happen is the attendance is going to go up by 1,000. Which is a good thing because the more people we have in the stands, we all like stadiums are full, but we also want to make sure that we have not only stadiums are full, but the more people there, they're buying concessions and stuff, right? So that's all a good deal. So find the price that maximizes revenue from ticket sales. Can't draw a picture for this one, can I? Okay. Well, I don't really mind what you said about guess and check. The question is, where would you start? Okay, all right. So Gigi said start 14 and okay, but what do I do with 14? Minus 1. Okay, all right. Gigi's got, she's 100% correct, okay? Now I'm just going to take what she did and I'm going to put it into a better understanding for you, okay? So uh, that Gigi recognizes is before I even subtract the 1, let's just, how much money are we making right now? 14 times 9,500. Would you guys agree? Like that's how much. So the revenue is going to be equal to the ticket price times the attendance. I mean, so that part you got to be able to come up with. That you got to start with. Well, how do I even make money in the first place? Now Gigi's doing the right thing. Then she's saying, well. So what if we take that 14 and we subtract 1 off of it? We would have to multiply that by 9,500. What? Plus 1,000. So we would see what we would get there. Now, I'm not really serious about doing guess and check the whole way through so much as maybe I can see a pattern. Maybe it's not decreasing by 1. Maybe it's decreasing by 2. Now I get 9,500 plus 2,000. Well, maybe I should decrease it by 3. There would be 9,500 plus 3,000. Well, now I see a good pattern going here. I mean, what's staying the same the whole time? And, yeah, so the 14 is staying the same. The 9,500 is staying the same. So can you finish off the equation then? Very good. You guys, this is one of the most challenging things as a teacher. How do you teach people how to do problems that, they may not know how to do right away? And there's many ways to set this up. I could have gone right to here and said, let's pull that equation from what we read here. But I think it's a whole lot better to just start to kind of, try stuff. All right. Well, I know I do that. Revenue in terms of X is, I first got to take 14 times 9,500. Very good, 133,000. I taught the class earlier. So. 9,500 times negative x, and then 1,000x times 14. That would be a 14,000x and a negative 9,500x. That would make a positive 4,500x. I got a negative 1,000x squared. Do you know what shape that looks like? That is a parabola. Yeah. Does it have a maximum? Thank goodness, because we're trying to maximize revenue. I find the maximum by doing negative b divided by negative b would be negative 4,500 divided by negative 2,000. Negatives cancel. Take 100 off. I got 45 over 20. Divided by 5, I got 9 over 4, or 2.25, right? So what the heck does that mean? Okay, so we found in this problem, look at our variable. We just found x, right? What does x represent? X represents the amount that we're decreasing the ticket price by, 2.25. So we're going to decrease it by 2.25, so $11.75. I appreciate it. Ultimately, as a math teacher, you love to hear, Mr. Gens, it's easy when you teach it, and then I'm so prepared that I'm able to go and discover these new problems on my own. Okay, and so I know, I understand. Okay, so but let's think critically here. Let's just think a little bit deeper here and look at this piece. Okay, this is really important. Okay, it's important you focus right here. This is my ticket price. Agreed? This is my attendance. Agreed? So, what number for X would make the ticket price 0? 14. Does it make sense if I lowered it by $14, I'd have 0 revenue? Right. My question is, suppose I did lower it by 14 bucks. Does it make sense that I would not lose? Does it make sense that I would not have any revenue at that point? Yeah, I'd be letting everybody in for how much? $2. Yeah, I mean they might like buy like popcorn and stuff, but I'm not getting any revenue from the ticket prices. Now, if I do that, what's going to happen with the attendance? It's going to go way up. So let's look at the other way. Okay, I could get zero revenue by lowering it by 14 bucks and making the ticket price zero, right? But let's think about the other way, because this would be concerning. This would be concerning to the people involved. What would make my attendance zero? I mean, obviously, if we raise this too much, the attendance would be zero, correct? What number here would give you attendance of zero for X? Negative 9.5. You solve this, you get negative 9.5. So if X was negative 9.5, that means the ticket price would be, yeah, $23.50, right? So all of a sudden you increase the ticket price $23.50, people are going to say it's too much money, I'm not going to come. So we know that the ticket price sits somewhere then between the 0 and the 23.5. Happens to sit exactly in the middle. Okay. Exactly. I just want you to try to understand that in context. At 23.50 is too much money. No people will come. Okay. Yes. 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 I mean, you guys, this is what we're doing. Okay. I'm just trying to show you. This is the top pinnacle foundation of being an excellent mathematician. Always find a way to check your answers. These are the things to think through. Now, I know you're ready to just kind of move on, but I'm trying to give you ways to continue to think about what you're doing. Yes, exactly. And so they could have that restraint right away, say it has to be less than 15,000 right away. Yep. Okay. All right. A rectangle, last one. Rectangle inscribed in a semicircle. Okay. So I've got a semicircle. What's the radius of the semicircle? So it looks like I got negative 16, positive 16, positive 16. What shape does it make? Yep. Somebody earlier said they knew their answer wasn't right because they came up with a square and the problem said a rectangle. Is this square or rectangle? Yeah, so be careful as you try to use that logic. Let's see, I've got x, y. You guys kind of seen this already, haven't you? It says what dimension should be to maximize the area. I know area is equal to base times height. So I need to come up with an expression for base. And I need to come up with an expression for the height. We'll see if you can help me out with the base. Base is still 2x. Yep. Yep. So the question is, what's the height? Very good. So Jessica recognizes that it's definitely going to be less than 16 because, that wouldn't work out. Yeah, the height's y. Good. So what's y? I mean, it was really nice on this previous problem where you just looked at it and it said, well, yeah, y is like a snake. It would bite you, right? It's just like right there. Okay. But this one, I don't see a y value. Shoot. Right. I probably wrote a bogus problem, huh? You know this. Section 1.8. Wouldn't it be awesome if we knew the equation for a circle, folks? Yeah. Folks, please look at that. What's the center of this circle? 2, -4. What's the radius? So therefore, what's the center of this one? So it's going to be x squared plus y squared is equal to 16 squared, 256. Okay. The equation for a circle is x minus h quantity squared, y minus k quantity squared equals r squared. What's the center of the circle? So therefore, 0 for h, 0 for k, you just have x squared plus y squared. The radius is 16, and that will give you 256. Grace is absolutely right. It's a half circle. So when you solve for y, we have y squared is equal to 256 minus x squared. When I square root both sides, I have to list a positive and a negative for that circle. Since we just have the top, as Grace said, do we want the plus square root or the negative square root? Plus, that's the top portion. The negative would be the bottom. So yes, y is the square root of 256 minus x squared. Now, some of you are sitting there and saying to yourselves, how can I honestly be expected to remember the equation for a circle? Well, your calculus teacher expects you to remember next year, and the ACT expects you to remember all the time. Now, if you didn't like trying to remember for the circle, I'll point out the other piece. If you simply just look at that distance, this is x, this is y, this is a radius of 16, Pythagorean theorem, right? Now, watch. When you do the Pythagorean theorem, x squared plus y squared is 16 squared. Isn't that what I just wrote? Because the equation for a circle, the Pythagorean theorem, is the same stinking things, folks. They're identical. Okay? We got that? All right. It's humbling, isn't it? It's humbling. It's like, my goodness. We just covered that a month ago, and where did it go? Yeah. Mackenzie, how does it feel to be an all-star? Mackenzie, how'd that calculus test go today? Way to be great. Way to keep up with your homework. All right, so let's go to Charlie's point, then we'll move on. Charlie's point is this. If I have the square root of 25 minus 16, okay? Can I just write 5 minus 4, which is 1? No, I can't, because what's 25 minus 16? 9. You can't do that. Not allowed. Okay? You can't distribute a power over addition and subtraction like that. No. Okay, so we're almost done. We've got the area in terms of x is equal to 2x times the root of 256 minus x squared. Do we know what the shape looks like? Well, it would be nice, but it's got an x squared underneath and has an x out front, so no, we don't know what it looks like. If it's not a parabola, we got no shot, okay? But we got to go to our graphing technologies. We go to y equals 2x square root 256 minus x squared, and I zoom standard. And at that point, I say, hey, Mr. Gens, my calculator ain't working. What am I supposed to do? And first thing I say is, well, first of all, look at the problem. What is the maximum value that x could be? 16. So maybe we should change our window so we have negative 20, positive 20. That way I'm sure to see the 16 in case it shows up, right? Second of all, what does the y value represent? Area. The y value represents area in the problem. So let's figure out a general area. Will, give me a number that x could be. Yeah, just give me a number for x. 4. Okay, so let's say x was 4. That would make this 8, right? Times the square root of 16, so it'll be a square root of 240, right? Square root of 240. And I don't even need my calculator for this. 8 times square root of 240 is going to be about 16. 8 times 16 is 128, right? So it looks like we're in the hundreds for our y values. So how about I go to negative 200 and positive 200, then maybe I'll see the entire graph, okay? So again, I just come up with a value to give me an idea of what to change my window to, and I press graph, and do you see everything? Looks like I should have gone a little bit higher, huh? So we'll go back in that window. Instead of negative 200, we'll go up, we'll go negative 400, okay? And positive 400. I press graph. Thank you, Cole. Now, here's what's really cool. At this point, you're like, oh, I don't even want to do the problem right now. I want to play with mathematics and see what if I included the negative? I get a bow tie. Look at that. Isn't that awesome? Yeah, all the shapes that you can get in mathematics. So, that's our shape. We want to find the maximum. I'll get rid of that piece, and I go to calculate, maximum number 4. Look at my half of a bow tie. It's kind of like half of an infinity symbol, but it wraps around too quickly on the end, so I'm not going to call it an infinity symbol. We'll call it a bow tie. There's a better example of the infinity symbol. So, sure, I can show you. 11.31 and 256. Somebody, please, in 6th hour college algebra, say something intelligent about what the heck these numbers mean. Thank you. 256 is the maximum area. We already know the maximum area, but it's not asking the maximum area. It's asking for the dimensions. So this is x. Why? Because I told it to be x. So what would then be the base? 22.62 by, and then what would the height be? How would I figure that out? Plug it in. When you do, you'll get 11.31. How do I get which part? I just take 11.31 and I plug it in here, and I'll get 11.31. You don't plug in 22.62. It says that the height is 256 minus x squared. So, okay, so Will, no, Will, let me help you out here, okay, because this is not coincidence. So watch this. Here's what it's doing. Here's the geometry of it. This is 11.31 here. So in each quadrant, it makes a perfect square. That's what it's doing. That's why it's the maximum. It's making a square, which has the largest area. It's just making 2 of them. So that's what it's doing. Yep. All right, so your assignment does not really change from yesterday. Here's what we got. First of all, I said, you know, those are 6 problems that you might want to give a shot. If you try them and you didn't like them, move on to something else. Here's 3 that you know, we kind of covered today that you might like. That's a total of 9. I said choose 7 of them. Now, I sure hope out of my 70 college algebra students, I have somebody out there who's willing to try all 12. And furthermore, I would love it if somebody did problem number 7. One of my favorite problems is Norman window problem. And when you solve it, don't just give the answer. List the answer in simplest terms of pi. I did the problem last night. I absolutely loved it. It was a good time. Made me smile. Problem number 12. Remember when we did the guy walking across the boardwalk and everything? Okay, well, that problem, again, this time you're minimizing the time it takes for him to do it. And if you look at my answer key right here, folks, you might say that would take a long time, right? There's problem number 12 right there at the bottom of my page. That's it. Do is difficult. I would expect that at least 25% of students, if not 50% of students, would need to come in and ask some questions about these. I'm guessing my room will be pretty bare in the mornings or after school yet, but I think that some of these problems are challenging. So